These are 10 winter survival skills that could save your life in a cold weather emergency, and you can master every single one of them without leaving your backyard. Most people assume survival training demands expensive gear and wilderness exceptions, but the skills that matter most when hypothermia sets in or when a winter power outage hits your neighborhood can be practiced during your weekend, right outside your back door. Winter doesn't mess around. The CDC tracks approximately 1,300 deaths annually in the US from excessive natural cold exposure, and your body temperature only needs to drop below 95 degrees Fahrenheit to enter hypothermia. That can happen in temperatures as warm as 50 degrees when you factor in wind and moisture. And exposed skin can develop frostbite in as little as 5 to 10 minutes when wind chill hits negative 20 degrees. Winter doesn't wait for you to be ready, and neither does an emergency. Let's start with the foundation of winter survival, which is fire. Building fires in dry summer conditions won't prepare you for winter, and the platform is the critical failure point most people miss. Snow insulates your fire from the ground, which sounds helpful until your fire melts the snow directly beneath it and sinks into slush. You need a platform 6 to 8 inches raised, built from green logs or rocks, or your fire extinguishes itself within minutes. The wood you choose changes everything in winter. Dead standing wood, sometimes called squaw wood, typically has 15 to 20% moisture content compared to wood lying on the ground at 40 to 60% moisture, which explains why one lights and the other smolders uselessly. Look up when you're gathering fuel, not down. Rookies waste 30 minutes on Tinder alone because they bring a golf ball-sized bundle like they would in summer. But in winter, that's not enough. You need a fist-sized bundle minimum because cold conditions require more initial heat to sustain combustion, and the feather stick technique maximizes your surface area. Each stick should have 20 to 30 fine curls, creating more contact points for flame, which means reliable ignition even when everything around you is cold and damp. The legal catch you need to know before you strike that first spark is that many municipalities prohibit open fires within city limits. The typical required clearance is 10 to 15 feet from structures, though that varies by locality, and some areas have year-round fire bans. One phone call to your fire department or a quick search of municipal codes will tell you what's allowed, and you're liable if your fire spreads, so verify what your homeowner's insurance covers. For backyard practice, a simple budget setup works perfectly. A $2 BIC lighter plus an $8 to $12 ferrocerium rod gives you reliable fire starting, with the lighter as your primary method and the ferro rod as your backup when your hands are too cold or wet to operate a lighter effectively. Skip the magnesium bars because they're difficult to use and the shavings are unreliable in real conditions. Practice this exact scenario. Build your platform, gather your wood, create your feather sticks, and light your fire wearing winter gloves, because if you can't do it with gloves on, you can't do it when it matters. A debris hut keeps you alive when exposure is the threat, and the specifications are precise. 3 to 4 feet wide, 5 to 6 feet long, 2 to 3 feet high at the ridgepole, with 2 to 3 feet of debris and leaves on all sides for insulation. That's not a suggestion, but the minimum for the shelter to function, and a properly constructed debris hut can be 20 to 30 degrees warmer inside than the outside air temperature. That difference is the gap between hypothermia and survival. Build time for a beginner runs 2 to 4 hours, which sounds like a lot until you consider that you're building something that could save your life. Practice makes you faster, and speed matters when you're already cold. 4 feet of packable snow in your yard means you can build a quinzhee, which is a snow shelter with remarkable physics. After you pile your snow, you wait 60 to 90 minutes for it to settle before you start excavating, and the walls need to be 12 to 15 inches thick, measured with guide sticks poked through from the outside as you dig. A properly built quinzhee can maintain an internal temperature of 32 to 35 degrees, even when the outside air is negative 20 degrees because of the insulation value of packed snow. The part that saves your life or ends it is ventilation. You need a 4 to 6 inch diameter hole at the roof peak to prevent carbon dioxide buildup, and without it, you're building a suffocation chamber. Mark your shelter entrance clearly if you're practicing in an area where people walk, and don't build under trees with heavy snow load because branches can break and collapse your shelter. The real bottleneck in shelter building is practice itself. You can read about debris huts and quinzees all day, but Until you've actually built one, discovered where your technique fails, and refined your approach, you don't have the skill. Your backyard is the perfect testing ground because failure has no consequences beyond a few wasted hours. Water purification becomes complicated when temperatures drop below freezing. So let's clear up the most common myth first. Clear snow is not pure and safe to drink because snow can contain bacteria, pollutants, and animal waste. Always purify, no exceptions. Boiling works, but you need to understand the numbers. A rolling boil for 1 minute kills 99.99% of bacteria, viruses, and parasites if you're below 6,500 feet elevation, and above that, you boil for 3 minutes. What boiling doesn't remove is chemical pollutants, heavy metals, or sediment. And in winter, your bigger problem is that water refreezes quickly after boiling. You need an insulated container or the water turns to ice before you can drink it. Filtration is where most people's gear fails them in winter because the majority of filters are only rated to 32 degrees Fahrenheit. If the water inside a ceramic filter freezes, the filter cracks and becomes useless, and the pore size matters for what you're trying to remove. You need 0.1 to 0.2 microns to filter out bacteria and protozoa. But that doesn't touch viruses unless your filter specifically rates for 0.01 to 0.02 microns, and filters also don't remove dissolved chemicals. In cold weather, you must keep your filter warm against your body or in your sleeping bag overnight, or it's destroyed. Chemical treatment slows down dramatically in cold. Iodine tablets lose effectiveness below 40 degrees and require 35 to 45 minutes of contact time, and chlorine dioxide works in cold conditions but demands a 4-hour wait time in freezing temperatures. Neither chemical treatment effectively removes cryptosporidium, which is a chemical-resistant parasite you definitely don't want in your system. UV purification depends on battery performance, and lithium batteries lose 20 to 30% of their capacity below freezing. UV is 99.99% effective on clear water, but if your water is turbid with sediment, the effectiveness drops significantly, and UV doesn't remove sediment or chemicals either. The decision point is this: if you need water fast and your source is clear, boil it. If you have time and can keep your filter from freezing, filtration gives you better tasting water without the fuel cost, and chemical treatment is your lightweight backup when gear fails. For backyard practice, use a budget option like potable aqua tablets at $8 plus coffee filters for sediment, or step up to a Sawyer Mini at $25 with a 100,000-gallon capacity. The premium choice is an MSR Guardian at $350, which handles virus protection and works in freezing temperatures, though that's overkill for most practice scenarios. Practice purifying water in your backyard using the actual containers and methods you'd use in an emergency. Learn how long each method takes and discover which method fits your skill level and patience. Cotton kills. And that's not dramatic language, but physics. Cotton retains 27 times its weight in water and loses 90% of its insulating value when wet, which makes wet cotton next to your skin in winter a fast track to hypothermia. Your layering system has 3 parts: base layer, mid layer, outer layer. The base layer wicks moisture away from your skin, and synthetic materials like polyester or polypropylene dry in 2 to 4 hours, while merino wool wicks moisture and retains 80% of its warmth even when wet, but takes 6 to 8 hours to dry. Cotton takes 8 to 12 plus hours and provides no warmth wet. So the choice is obvious. Your mid layer provides insulation, and fleece weight tells you the temperature range. 100 grams per square meter keeps you comfortable to about 40 degrees. 200 grams works down to 20 degrees, and 300 grams handles 0-degree temperatures. Down is incredibly warm for its weight, with 650 fill providing warmth to around 30 degrees and 800 fill working down to 10 degrees, but down loses all insulation value when wet, while synthetic insulation retains 60 to 70% of its warmth even when wet. Know what you're wearing and what it can handle. The outer layer blocks wind and water, and you need a waterproof rating of at least 10,000 millimeters for winter conditions, with 20,000 millimeters better for extended exposure. Breathability matters too, because at least 10,000 grams per square meter per 24 hours prevents sweat from accumulating inside your layers, which would defeat the entire purpose of your layering system. Hypothermia stages need to be recognized because this saves lives. Mild hypothermia happens when your core temperature drops to 95 to 90 degrees, with shivering, confusion, and loss of fine motor skills. Moderate hypothermia at 90 to 82 degrees is where violent shivering actually stops, severe confusion sets in, and drowsiness takes over. While severe hypothermia below 82 degrees means unconsciousness, irregular heartbeat, and high risk of death. You lose heat 25 times faster when you're wet, so stay dry, keep moving to generate metabolic heat. There's debate about the exact percentage of heat lost through your head, with some studies showing 40 to 45% and others arguing it's closer to 7 to 10%, but covering your head is still critical regardless of the precise number. Watch for the umbles, stumbling, mumbling, fumbling. If you or someone with you starts exhibiting these signs, you're looking at hypothermia and you need to act immediately. For budget layering practice, hit thrift stores where wool sweaters run $5 to $10 and fleece costs $10 to $15, letting you build a functional layering system without spending a fortune. A mid-range synthetic puffy jacket runs $60 to $100, and premium 800 fill-down jackets cost $200 to $300, though you don't need premium to learn the principles. Knots are simple until you try tying them with winter gloves on, and that's when you discover which knots you actually know versus which ones you just think you know. The bowline creates a fixed loop that won't slip, and you use it to secure tarps and create anchor points, but the problem in cold weather is that it's difficult to tie with gloved hands. You need to practice this knot 50 to 100 times with winter gloves before you can rely on it in an emergency. And static kern mantle rope or paracord maintains flexibility better than natural fiber in cold conditions. So use the right rope for your practice. The taut line hitch gives you adjustable tension on shelter guy lines, and once you tie it, you can adjust the tension without removing your gloves. That's a massive advantage when your hands are already cold. And the trick is to pre-tension your lines in warm conditions if possible, because knots tighten further as rope contracts in the cold. The clove hitch offers quick attachment to trees or poles, but it can freeze in place with ice buildup, and when that happens, it becomes extremely difficult to untie. The trucker's hitch provides a 3-to-1 mechanical advantage through a pulley effect, giving you maximum tension on tarps and shelters, though in cold weather, synthetic rope becomes stiffer and requires more force to achieve the same tension you'd get in warmer conditions. Rope itself behaves differently in cold. Nylon loses about 10% of its strength below freezing and becomes stiff, while paracord maintains flexibility down to negative 40 degrees, which makes it the superior choice for winter use. Natural fiber rope absorbs moisture, freezes solid, and becomes brittle. The practice requirement is clear: tie each essential knot 50 to 100 times with your actual winter gloves on. When you can tie a bowline, taut line hitch, clove hitch, and trucker's hitch without looking and without removing your gloves, you have the skill. But until then, you're just hoping. Getting found is its own skill set, and winter makes it harder. A signal mirror or any reflective surface is visible up to 10 to 15 miles on a clear day, which makes it one of your most effective visual signals. For a signal fire, you add green branches to create white smoke that contrasts against snow. Use evergreen branches, charred wood, or bright fabric against snow, and make your signals at least 8 to 10 feet long for aerial visibility. Sound travels differently in winter, and a whistle carries 1 to 2 miles in still winter air compared to only half a mile for shouting. Cold, dense air carries sound farther, but irregular snow surfaces can muffle it, and 3 blasts on a whistle is the universal distress signal. Repeat it every minute until you get a response. Your cell phone battery loses 20 to 40% of its capacity below freezing, so keep your phone warm against your body, not in an outside pocket. Emergency beacons with lithium batteries function down to negative 4 degrees Fahrenheit, which gives them a significant advantage over your phone in extreme cold. Winter visibility challenges are substantial because whiteout conditions reduce visibility to less than 400 feet. Snow glare reduces signal detection, so position your signals with the sun angle in mind, and if you're under dense evergreen canopy, you lose 70 to 80% of your signal visibility from above. Know your environment and adjust accordingly. For backyard practice, set up signal mirrors and practice aiming reflected light at specific targets. Build a signal fire and see how different materials affect smoke color and volume. Then test how far your whistle carries in winter conditions. The more you practice, the more confident you'll be when visibility is your lifeline. when your gear fails or you don't have the right equipment, improvisation extends your survival window, and understanding R values, which measure thermal resistance, tells you what actually works. Dry leaves or grass provide an R value of about 2.5 per inch, which is comparable to basic foam, while newspaper gives you an R value around 3.0 per inch, though you need 10 to 15 sheets for basic insulation. Bubble wrap has an R value of 1.0 per inch, but it's windproof, which adds to its effectiveness, and cardboard delivers an R value of 3.0 per inch, making it excellent ground insulation. For improvised mittens, plastic bags filled with dry leaves can extend hand warmth for 30 to 45 minutes. Wool socks pulled over your hands give you better dexterity than mittens while still providing warmth, and duct tape can temporarily waterproof fabric, though it won't last long in hard use. A vapor barrier is a plastic bag worn inside your sock to prevent sweat from wetting your boot insulation. But the caution here is that it creates moisture buildup, so you need to change it every 2 to 4 hours to avoid trench foot. For an insulated ground pad, 3 to 4 layers of cardboard equal a thin foam pad in insulation value, and a 6 to 8 inch layer of pine boughs provides basic ground insulation. The reality check is that improvised gear is supplemental, not a replacement for proper equipment. It's most effective as an emergency backup or as a practice exercise to understand the principles, and moisture management remains the critical issue with all improvised insulation. Practice making improvised gear in your backyard so you understand what works, what fails, and how long each solution actually lasts. Knowing how to recognize and treat frostbite and other cold injuries is the difference between full recovery and permanent tissue loss. Frostnip is the mildest stage, showing pale skin, numbness, and tingling. The damage is surface only and reversible, with treatment being gradual rewarming using body heat or warm water between 98 and 105 degrees Fahrenheit. Superficial frostbite shows waxy or white skin that feels hard on the surface but soft underneath, and the damage extends to skin and subcutaneous tissue. Rewarm in 98 to 105 degree water for 15 to 30 minutes, and do not rub the affected area because that causes severe tissue damage. The critical rule is do not rewarm if there's any possibility the area will refreeze, because refreezing causes catastrophic tissue damage far worse than staying frozen. Deep frostbite means the tissue is completely hard with no sensation, and the skin may be blue or gray. This requires professional medical care only. Keep the area frozen until evacuation is possible, because the risk at this stage is permanent tissue loss and amputation. Trench foot is a non-freezing cold injury that develops after 12 to 24 hours of wet, cold conditions above freezing. Symptoms include tingling, pain, swelling, and blisters, with prevention being changing socks every 4 to 6 hours and drying your feet thoroughly. Recovery can take weeks to months. The critical first aid principles are never rub frozen tissue because you'll cause ice crystal damage internally. And keep your warm water temperature between 98 and 105 degrees, where it should feel warm but not hot to normal skin. Rewarming is extremely painful, so ibuprofen is recommended for pain management. The American Red Cross is clear that all cold injuries beyond frostnip require medical evaluation. Document the time of injury and the time you began rewarming for the medical team, because this information affects treatment decisions. Practice recognizing the signs of cold injury on yourself and others during your backyard winter training. Navigation becomes exponentially harder in winter when landmarks disappear under snow and daylight shrinks. Magnetic declination varies by location, running about 10 to 15 degrees west on the east coast of the US and about 12 to 17 degrees east on the west coast. You have to adjust your compass accordingly, or your navigation will be off by miles over distance, and liquid-filled compasses can bubble or freeze below 0 degrees Fahrenheit. Metal objects like steel tools, belt buckles, and phones affect compass accuracy within 12 to 18 inches, so keep them away from your compass when taking a bearing. Winter creates specific navigation problems because snow covers trails, blazes, and cairns. On December 21st at 40 degrees north latitude, you only get about 9 hours of daylight. And cloud cover interferes with GPS signals, while tree canopy compounds the problem, dropping your GPS accuracy significantly. GPS devices lose 30 to 50% of battery capacity in freezing temperatures, which means your electronics fail exactly when you need them most. The shadow stick method uses the sun's movement to find direction, and it's accurate to within 10 to 15 degrees with a 30-minute observation period, while the watch method points your hour hand toward the sun, with halfway between the hour hand and 12 being south in the northern hemisphere. Both methods require visible sun, which you can't count on in winter storms. Star navigation works if you have clear night sky, and Polaris, the North Star, is always within 1 degree of true north. It's located at the end of the Little Dipper's handle, about 5 times the height of the pointer stars from the Big Dipper. Natural indicators like moss growth and tree growth patterns have low reliability because moss faces multiple directions depending on moisture and microclimate. Tree growth is affected by prevailing winds, but local conditions vary too much to trust this method, and snowmelt patterns on south-facing slopes happen faster, though wind, shade, and elevation affect this. Best practices carry a paper map, a compass, and a GPS. Mark waypoints in your backyard for practice and learn dead reckoning, which is navigating by pace, count, and direction. When you can navigate your neighborhood in winter using only map and compass, you have a foundation you can trust. Your body burns 2 to 3 times more calories maintaining core temperature in cold environments, with normal activity requiring about 2,000 to 2,500 calories per day, and winter survival conditions pushing that to 3,500 to 5,000 calories per day. Shivering alone burns 400 to 600 calories per hour. Winter foraging is possible, but you need realistic expectations. White pine needle tea contains 5 times the vitamin C of an orange, and cattail roots have starch content similar to potatoes, and they're available under ice and snow. Dandelion roots remain available until the ground freezes solid. Acorns require leaching by boiling them and changing the water 3 to 4 times to remove bitter tannins, and rose hips contain 20 times the vitamin C of oranges, and they're available through winter. The safety requirement is that positive identification is mandatory because 80% of plant poisonings occur from misidentification. The universal edibility test takes 15+ hours, which is not practical in an actual emergency. And regional variation means the same species can differ in edibility based on location. So local field guides are necessary. Plants near roads carry salt and chemical contamination from winter road treatment. The realistic assessment you need to hear is that winter foraging provides vitamins and nutrients, not significant calories. 100 calories per hour of foraging effort is optimistic in winter conditions. For backyard practice, identify edible plants in the growing season and mark their locations. Learn what they look like dormant in winter because it's dramatically different from their summer appearance, and consider propagating edible native plants in a corner of your yard for year-round identification practice. Follow leave no trace principles by not harvesting from protected areas. Take only what you need and leave enough for wildlife and regrowth, and the 1 in 20 rule says never take more than 5% of any plant population. These 10 skills form the foundation of winter survival, and your backyard is the training ground where failure costs you nothing but time. Fire building in snow, emergency shelter construction, water purification in freezing conditions, proper layering, essential knots with gloves on, effective signaling, improvised gear, cold injury recognition, winter navigation, and realistic foraging all address specific failure points that could cost you your life in a real emergency. The progression is straightforward. In your first 2 to 4 weeks, master 1 fire starting method, build a basic debris shelter, practice 3 to 4 essential knots, and learn layering principles. Over 1 to 3 months, you work on fire in wet conditions, quinzhee construction, compass navigation, and cold injury recognition. And after 3 to 6 months, you should be comfortable with multiple fire methods in challenging conditions. Improvised gear fabrication, navigation without GPS, and winter plan identification. Practice weekly for 30 to 45 minutes on fire skills. Every 2 weeks, drill your knots and layering systems, and monthly build a shelter or run a navigation exercise. Each season, integrate all your skills in a 4 to 6 hour winter practice session that tests everything at once. The average person believes survival skills require wilderness expeditions and specialized expensive gear, but they're wrong. The skills that keep you alive when hypothermia is setting in, when a winter storm knocks out power to your neighborhood for 72 hours, when your car breaks down on a rural road in January, Those skills are practiced in your backyard wearing the clothes you already own using methods that cost almost nothing. Approximately 1,300 people die each year in the US from cold exposure, and most of those deaths are preventable with basic knowledge and practiced skills. Your backyard is where you build the muscle memory that overrides panic when everything goes wrong, and where you discover which gear works and which gear fails before those failures matter. Start this weekend by building a fire platform on snow, tying a bowline with your winter gloves on, and layering your clothing to go outside for an hour to see what actually keeps you warm. Each small practice session moves you from theoretical knowledge to functional capability. The question isn't whether you'll face a winter emergency, but whether you'll have practiced the skills that make the difference between a scary story and a tragedy. Your backyard is waiting.